Hey seniors, okay, today's lesson, ellipses, page 631. Ellipses, page 631. So first of all, let's define an ellipse. An ellipse is a set of all points in the plane, the sum of whose distances from two fixed points called foci is constant. Now, F1 and F2 are the foci, and the midpoint C of the line segment joining the foci is called the center. So here we have an ellipse. We have the two fixed points, foci, focus 1, F2, and the midpoint, okay, the midpoint of the line segment containing the foci is the center. Okay? Now, the paragraph of an ellipse is centered at the origin. Okay? An ellipse has two axes of symmetry. In this case, the x-axis and the y-axis. Now notice that the ellipse intersects each axis two times. So in the x-axis, it intercepts the axis of symmetry at this point, point A, and at point D. In the y-axis, the second axis of symmetry, it intersects the axis at B and E. Okay? Now, the longer segment AD, which contains the foci, is called the major axis. The shorter segment BE is called the minor axis. Now, the endpoints of this axis, in this case for the major axis, the endpoints are A and D, and the endpoints for the minor axis B and E are called the vertices of the ellipse. Okay? Now, the standard form of the equation of an ellipse is x squared over a squared plus y squared over b squared equals 1. This is the equation of an ellipse whose center is at the origin and whose foci are on the x-axis. Now, A is the distance from the center to the major axis, and B is the distance from the center to the minor axis. So in this case, A will be the distance from the center to the major axis, either from C to A or from C to D. And B, it will be the distance from the center to the minor axis. That means from C to B or from C to E. That's how we define A and B in the equation. Now, in all ellipses, A squared is always greater than or equal to B squared. Now, the equation y squared over A squared plus x squared over B squared equals 1 is the equation of an ellipse whose center is at the origin and whose foci are on the y-axis. Now, the standard form of the equation of an ellipse with center other than the origin is a translation of the parent graph to a center HK. Now, it is very important for you guys to have this chart or this table in a separate piece of paper. Standard form of the equation of an ellipse, okay? the orientation of the ellipse and the description. Notice x minus h squared over a squared plus y minus k squared over b squared equals 1, where c squared is equal to a squared minus b squared. This equation in a standard form, the orientation of the graph will be that the major axis will be parallel to the x-axis. Okay? So that means the description. The center will be located at HK. The foci will be located at the points H plus minus C, K. The major axis is the line y equals K, and the major axis vertices will be located at H plus minus A, K. The minor axis will be the graph of x equals H, and the minor axis vertices will be located at H, K plus minus B. Okay, these are the points that are important to know in order to graph ellipses. Now, the standard form of the equation of the ellipse y minus k squared over a squared plus x minus h squared over b squared equals 1, and again, where c squared equals a squared minus b squared, the orientation of the graph will be that the major axis will be parallel to the y-axis. Okay, the center will be located at HK. Foci will be located at H, K plus minus C. Major axis will be the line x equals H. The major axis vertices will be located at H, K plus minus A. The minor axis will be the line y equals K, and the minor axis vertices will be located at H plus minus B, K. Okay, so with these formulas, we can start working on the problems. So if we look at example 2, okay, look at example 2. So sample 2 says, consider the ellipse graphed. Write the equation of the ellipse in a standard form. So here we have the graph of, so if you look at the graph of the ellipse, we notice that we have the center, 2, negative 4. We know this point, it's one of the vertices of one of the axes, located at 8, negative 4, and another vertex, 2, negative 7. Now notice that the orientation of the ellipse is horizontal. That means that the major axis is parallel to the x-axis, and the minor axis is parallel to the y-axis. So from the graph, we note the following. Center is located at 2, negative 4. Okay? By definition, we note that the center is located at HK. Okay? So center is 2, negative 4. So that means it's located at HK. So that means that H equals 2, K equals negative 4. Okay? Now, the distance from the center to one of the vertices, to the vertices of the major axis, from the center to negative 4 to 8, negative 4, the distance is 1, 2, 3, 4, 5, 6. So we know that A equals 6. Now, B is the distance from the center to the one of the vertices of the minor axis. So it will be from 2, -4 to 2, -7. So the distance will be 1, 2, 3. So B equals 3. Okay? Now, since the orientation of the ellipse, the major axis is parallel to the x-axis, then the equation will be x minus h squared over a squared plus y minus k squared over b squared equals 1. Now all we have to do is substitute. So that is x minus h. H was equal to 2. X minus 2 squared over a squared. That is 6 squared plus y minus k. Value of k, -4 squared over b squared. That is 3 squared equals 1. Now we simplify. X minus 2 squared over 6 squared, that's 36, plus y plus 4 squared over 3 squared, that's 9, equals 1. Okay, so that will be the equation in a standard form of the ellipse that it was graphed. Now, part B, it says find the coordinates of the foci. So if we look at our table, foci is located at h plus minus c k. So foci will be located at h plus minus c k. We already know the value of h. We already know the value of k. What we're looking for is the value of c. Now, remember, c squared equals a squared minus b squared. So that means c squared equals a squared minus b squared. Therefore, c squared equals a squared was 36 minus b squared 9. C squared equals 36 minus 9. That's 27. Okay. Now we find the square root. So c equals square root of 27. So foci will be h 2 plus minus square root of 27 -4. Okay. So that means the 2 points will be 2 plus square root of 27 -4, and f2 will be 2 minus square root of 27 -4. So that will be the coordinates of the foci. Okay, we're going to leave them like that because those are the exact answers. If we estimate, square root of 27 would be like 5.1. So 2 plus 5.1, that's negative 7.1, negative 4. And 2 minus 5.1, that's like negative 3.1, negative 4. So that will be the coordinates of the foci. Now, in example 3, it says for the equation y minus 3 squared over 25 plus x plus 4 squared over 9 equals 1, find the coordinates of the center, the foci, and vertices of the ellipse, then graph. Okay? Now, look at the equation. Y minus 3 squared over 25 plus x plus 4 squared plus 9 equals 1. In this case, we're talking of an ellipse whose major axis is parallel to the y-axis. So we're talking about the equation in a standard form, y minus k squared over a squared plus x minus h squared over b squared equals 1, right? Now, and the equation that we have is y minus 3 squared over 25 plus x plus 4 squared over 9 equals 1. So in this case, the center is located at HK. HK. So H, in this case, since it says x plus 4, that means that H is equal to negative 4. Why negative 4? Because x minus negative 4 it's equal to, simplified, it's the same as saying x plus 4. So h equals negative 4 and k equals 3. So the center will be located at negative 4, 3. Okay, so that's our center. So we're done with the center. Now, foci. The foci are located, in this case, foci will be h, k plus minus c. H, k plus minus c. Now notice, in this case, a squared equals 25 and b squared equals 9. Right? A squared equals 25, b squared equals 9. So we already know the values of h and k. Let's find c. And by definition, we know that c squared equals a squared minus b squared. So that means c squared equals 25 minus 9. C squared equals 25 minus 9, 16. We find the square root. C equals 4. Now that we have the value of C, then the foci will be h, negative 4, comma, k, 3 plus minus 4. Okay? So that means that the foci would be negative 4, comma, 3 plus 4, and foci 2, negative 4, comma, 3 minus 4. So we can simplify this. Negative 4, comma, 3 plus 4, that's 7. And negative 4, 3 minus 4, that's negative 1. So this will be the foci. Okay? Now we have to find the vertices. Remember that we have two vertices. The major axis vertices which by definition will be h k plus minus a, h k plus minus a. Now we know h and k, and we know that a squared equals 25. That means that a equals square root of 25, a equals 5. So the major axis vertices will be located at h negative 4, comma, k 3 plus minus a 5. So that means negative 4 comma 3 plus 5 and negative 4 comma 3 minus 5. We can simplify that. Negative 4 comma 8 and negative 4 comma negative 2. So this will be the vertices of the major axis. Okay, now let's find the vertices of the minor axis. Minor axis vertices. Okay, by formula, the minor axis will be h plus minus b k. H plus minus b k. We know that b squared equals 9. So b equals square root of 9. That means that b equals 3. So the minor axis vertices will be located at h, that's negative 4 plus minus 3, k, 3. Okay, so that means negative 4 plus 3, 3, and negative 4 minus 3, 3. Now we simplify negative 4 plus 3, that's negative 1, 3, and negative 4 minus 3, that's negative 7, 3. So this will be the vertices of our minor axis and the vertices of our major axis. Okay? So we have center, foci, and the vertices. Repeat, center, foci, and our 4 vertices. Now all we have to do is graph. So our graph, the center is located at negative 4, 3. Negative 1, negative 1, negative 2, negative 3, negative 4, 3. So it will be located at here. That's the center of our graph. Okay, and I'll label this with C for center. Now the foci are located at negative 4, 7. Negative 4, 1, 2, 3, 4, 7. 3, 4, 5, 6, 7. Negative 4, 7. 1, 1, 1, 2, 3, 4, 5, 6, 7. So it will be here. And at negative 4, 7 and negative 4, negative 1. Out here. So I'll label this as F1, F2. Those are our foci. Now, the major axis vertices is negative 4, 8. This is negative 4, 7. Negative 4, 8 will be right over here. And negative 4, negative 2. Okay. And the minor axis vertices is negative 1, 3, negative 1, 3, and negative 7, 3. 1, 2, 3, 4, 5, 6, 7, 3. Okay, now the proper way to graph this is using thumbnails. You put a thumbnail here or a thumb. So you put tags, tachuelas, on the two focus, right? So they are fixed points, and you tie a string from focus 1 and focus 2, and with your pen, you're going to open wide to the vertices, and that's how you're going to draw. That's how you draw the ellipse. But in this case, we're going to be sketching our graph because we don't have that time to be. Okay. Now notice, this is our minor axis. This is our major axis, and it passes through the two focus. This is our center, okay? And that's how you graph the ellipse. Okay, as with the circle, the standard form of the equation of an ellipse can be expanded to obtain the general form. The result is a second degree equation of the form ax squared plus cy squared plus dx plus ey plus f equals 0, where a is not equal to 0 and c is not equal to 0, and a and c have the same sign. An equation in general form can be rewritten in a standard form to determine the center at hk, the measure of the semi-major axis A, and the measure of the semi-major axis B. So let's look at example 4. Okay, so example 4 says, find the coordinates of the center, the foci, and the vertices of the ellipse with the equation 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. Then graph the equation. In our case, we're going to sketch the equation. Yes, we're going to sketch the equation. So what do we have to do here? We're going to put our x's together and the y's together. So we get 4x squared minus 40x plus 9y squared plus 36y equals negative 100. Okay, now we're going to group them. Notice that 4x squared and 40x can be, it has the greatest common factor of 4, so we can put 4 away, outside and we have 4 times x squared minus 10x. 9y squared and 36y, have the greatest common factor is 9, so we can take out that 9 out, and we'll get 9y squared plus 4y equals negative 100. Okay, Now we're going to complete the squared for x and for y. So remember, to complete the square, we must find half of b squared. In the first part, b equals 10, negative 10. Sorry. So that means negative 10 divided by 2 squared, that's equal to negative 5 squared equals 25. And in the second case, b, half of b squared, in this case, b equals 4. So that means 4 divided by 2 squared equals 2 squared equals 4. Okay? Now that we have that, we complete the squared. So we get 4 times x squared minus 10x plus 25 plus 9 times y squared plus 4y plus 4 equals negative 100. Now, we added inside 25. So we have to, in order to keep it balanced, we have to add 25 on the other side. But we're also multiplying by 4, so we're going to multiply that 25 by 4. And then we multiplied in y. We added 4 for y, so we have to add 4 in y. And since we're multiplying by 9, we have to multiply that 4 times 9. Okay? Now we simplify. The binomial squared will be, in this case, 4 times x minus 5 squared plus 9 times y, positive 2, plus 2 squared equals negative 100. 25 times 4, that's 100, plus 9 times 4, 36. Negative 100 plus 100, that's canceled. So we get 4 times x minus 5 squared plus 9 times y plus 2 squared equals 36. Okay? Now, we have to divide both sides of the equation by 36. Why by 36? Because we're trying to make this equal 1. So we divide by 36. Okay? Now look, 4 and 36 are divisible by 4, so we can cancel here 1, and here we get 9. So that would be x minus 5 squared over 9 plus 9 and 36 can divisible by 9. So we get 1 on the top, y plus 2 squared over 4 equals 1. Okay. Now we have our equation in the standard form. Now that we have our equation in a standard form, we can find the center, HK. Now notice, in this case, 9 is greater than 4, 9 is over x, below x I mean, so this means that the ellipse, its major axis is parallel to the x-axis, so the center will be h, in this case h equals 5, and k will be equal to negative 2. So the center will be 5, negative 2. Okay? Now, foci. Foci will be h plus minus c k. We know the values of h and k, so now we have to find c. We know that c squared equals a squared minus b squared. C squared equals 9 minus 4. C squared equals 5. Find the square root. C equals square root of 5. So that means that Foki will be h 5 plus minus c square root of 5 k negative 2. Okay? So that means Foki will be 5 plus square root of 5 negative 2 and 5 minus square root of 5 comma negative 2. Okay, so we can write our 4k just like we have on the top. Square root of 5 is not a perfect square, so we're going to have to estimate anyways. Now let's find the vertices. The major axis vertices in this case will be h plus minus a k. We know the values of h and k, and we know that a squared equals 9. So we find the square root. A equals 3. So that means 5 plus minus 3 negative 2. So that is 5 plus 3 negative 2 and 5 minus 3 negative 2. So we can simplify 8 negative 2 and 2 negative 2. The only thing left is the minor axis vertices. Let me do it over here. Minor axis vertices. The minor axis is h plus minus b, h comma k plus minus b. We know the values of h and b and k, and we know that b squared is equal to 4. So we find the square root. That means that b equals 2. Okay? So h 5 comma k negative 2 plus minus 2. So that means 5 comma negative 2 plus 2 and 5 comma negative 2 minus 2. We simplified 5 comma 0 and 5 comma negative 4. Now we have all the information. Now we can sketch our graph. So the center was located at 5 negative 2, 5 negative 2, C for center. Foci was at 5 plus minus square root of 5 negative 2. So since it is not a perfect square root, we don't have to graph the foci because we will be estimating. So all we're gonna graph are the major axis vertices and the minor axis vertices. So the major axis was 8 negative 2 and 2 negative 2. And the minor will be 5 0, 5 0 and 5 negative 4. I will sketch the graph. Okay, we connect smooth curves connecting the 4 vertices, and this is what we get. And this will be our sketch. Okay, this will be our minor This would be our minor axis. This would be our major axis, sorry. Right? And that would be the sketch of our ellipse. So that's it, guys. If you have any questions, please, you can text me and I'll try to help you. See you guys next week.